Hello everyone, I'm Namrata Maditripathi, a PhD student at IIT ISM Dhanbad. Welcome to the problem solving session week 12, in which we will discuss the problem related to the course Differential Equation for Engineering. Today's we will discuss the question related to Laplace equations. So these are the problems we will discuss in this session. These five type of problem we will discuss. First two based on Cartesian form of Laplace equation, and rest of the three are polar form of Laplace equation. They are different cases. Okay, we'll start from question 1. Okay, try to solve question number 1. How to proceed? Okay, the question 1 is find the solution of the boundary value problem. So this is Laplace equation where x is from 0 to some a and y is also from 0 to b. So these are the boundary conditions we are given. We have to find ux comma y. That means heat distribution in the rectangular bar. Okay, first of all, we'll write the unknown function. First of all, we will break this into domain. That means two part, v plus w. V is also satisfy Laplace equation, w is also satisfy Laplace equation, such that v and w satisfies 1. Let's say this is 1, along with we'll consider problem 1n as v x comma 0 x and rest of the boundary condition like x comma b is 0, v x 0 comma 0 comma y is 0, v a comma y is 0. This is problem 1. For this we can say x is from 0 to a, and for this is x. Okay, so this is problem 1, and problem 2 can be written as is 0 comma y e की power y, because another condition is given e की power y. So we will consider 0 comma y is e की power y and rest other side of boundary will consider it 0. Here we can write it as fine. So in this problem we have to solve for u. So first of all we will break the u in two parts, v plus w. That means we break the boundary condition in two parts. This is v boundary and this is w boundary, domain, sorry. Okay. So this is x and rest are 0. Okay. Similarly here we will consider this is w 0 comma y is e की power y and rest are 0. Okay. So we will solve these two problems one by one so that we can tell the solution for u. Okay, for the unknown function u with the help of v and w. So first of all we will solve for v and then w, and then we will combine these two solutions. How to solve for v? For this, let v xy in the form of variable separable form. So it will satisfy equation 1. So by what was equation 1? Uxx plus uyy is equals to 0. Fine. So if V satisfy this equation, so Vxx plus Vyy equal to 0. So uh, after satisfying equation 1 for Vxy, we will get fine. That implies okay, these the left hand side is in x variable and this is right in the right hand side this is in the y variable, so the ratio will equal to some constant. Okay, now from here you can proceed uh, with the help of boundary condition. You can form the Sturm-Liouville problem. By the boundary condition, v0 comma y will use first two boundary condition, not first, we'll use the last two boundary condition. Okay, for all y. From here, if you put x0 from one and from another, you will get this boundary condition. The system becomes, this is SL problem is SL problem. Okay, is there any doubt till now? Is it clear?
Yes, ma'am.
Okay, now we have to solve this SL problem. We have already seen by solving this problem it is obtained eigenfunctions are we have already solved this SL problem. You can write in details also, but I'm skipping this part because we have already done the corresponding eigenvalues fine. Now we have to solve for yn also, so that we can write the solution for v. Okay, now with the help of lambda n we can write the for the problem for yn. I am substituting the value of yn here, lambda here, so that we can solve for yn also. Fine. What will be the general solution? As general solution, can I write the general solution as? It is simply ordinary differential equation. So there are two roots, e की power this is n, e की power one root is n pi by a into y, another we will get e की power minus n pi into y. These two roots we will get, so we can write the general solution in the form, in this form. Fine. Now what will be the value of vxy by the principle of superposition? Fine. Then combining x and y, that means v and xy can be written as xn into y1, where n is varying from 1 to infinity. We have solved for xn, which is an e की power n pi upon a y plus bn e की power minus of n pi upon a. And what is solution for xn? xn is sine n pi upon a into x. Into x. Okay. Fine. So this is solution for xy, but we have to find out, we have to find the constant terms a and bn by using the rest of boundary condition. So the boundary condition, using this boundary condition, implies so at the place of y I am writing b bn e की power minus n pi a into b into sine n pi by a at the place of x, just x. So this term cannot be equal to 0. So From here, that imply is equals to minus b of n e की power n pi ba for all n. Fine. Similarly, we can apply another boundary condition. The condition, boundary condition. Vx0 is 0, where x is from. This implies so with the help of this equation, if we put an e की power n pi b upon a at the place of an, if we write bn into this e की power term and into e की power minus b of term, that means the value of an from here, if we put, and then we will put at the place of y is equals to 0, then take an outside and first term is n pi y upon a, that means 0 upon a. Okay, and second term is e की power 2 n pi b by a minus n pi on a into 0 at the place of y, and sine n pi upon a x is equals to 0, where x is from 0 to a. I'm just putting the value of an here and apply the boundary condition, then we will get this equation. Fine. From here, we have to find the value of this constant term. This will become 1 and this will become 2 n pi b by a is equals to integration of x into sine n pi upon a into x, and the integration of denominator term will be a by 2, that means 2 by a dx, where n is varying from 1 to infinity. Now if we integrate it by part, we will get sine of integration for sine is minus cos of n pi by a into x upon limit is 0 to a, and this will become 0. Because after putting limit a, you will get sine n pi, that will, the value of sine n pi will 0. After putting the limit, you will get 2a n pi, and the value of cos of n pi minus 1 की power n plus 1. Fine. This is the value for an 1 minus e की power. So from here, the value of an inverse. Fine. So what will be the value of vxy after putting the value of an 2a minus 1 की power n plus 1 1 minus e की power 2 n pi b by a inverse into e की power n pi by a y minus e की power 2 n pi b by a minus 2 n pi b by a minus n pi a upon y into sine n pi a into x. Fine. Just I'm putting the value of an and bn in terms of an, and you will get this expression. You can rewrite this expression also in simpler form. Uh, you can write e की power minus n pi b by a into y minus b, and the another term minus it will take common, and sine n pi upon a into x. I'm just rewriting this bracket term inverse 1 minus e की power 2 n pi b by a. If we take it in the denominator and after multiplying with another bracket, you will get this expression. So from here, this is sine hyperbolic. Fine. 2 sine hyperbolic. This term is sine hyperbolic, I think, and this is also sine hyperbolic. Both are so sine hyperbolic y minus b upon a, and I think here minus 1 is also there. 2n pi sine hyperbolic n pi b by a into sine n pi on ax. Fine. 2 will cancel out. So this is v of x comma y. Okay. Is there any doubt? So this is the solution for problem 1, which we are here we are constructing two problem 1 and 2 for solving this problem u. So problem 1 is completed. Fine. Now we'll solve for problem 2. Now we solve problem 2. For this, again we'll let w is function of xy in the form of okay. The boundary condition when x is from 0 to a. This implies okay, first of all we have to substitute this in equation 1. Then again, similar to the problem 1, we will get so by equation 1, after substituting this expression, you will get some constant. Lambda is some constant. The boundary condition we have constructed so this boundary condition implies if you use this boundary condition, then you will get y0 from 1 and from 2 yb0. Okay. So this is a regular SL problem. Y dash is equals to lambda y with boundary condition. So again we have to solve for y and then we will solve for x so that we can find the solution for w. Fine. So this is SL problem. We have already find the eigenvalues, eigen function for this problem in previous session. So I'm going to write the eigenfunction. By solving SL system, we obtain the eigenfunction everyone know how to solve SL problem taking three condition on lambda because lambda is real number. So taking lambda 0, lambda less than 0, lambda greater than 0, and after applying boundary condition you will get the eigenfunction corresponding to the eigenvalue minus n pi b whole square. Fine. Again where n is from 1 to and so on. Okay. So with the help of this lambda we will solve for x. We will solve for x. For lambda the problem we will find the general solution for xn with the help of lambda. What will be the general solution for this xn? This is simple ordinary differential equation. So after writing auxiliary equation you will find two roots so that you can find the general solution as an e की power n pi upon b one roots and another root is n pi minus n pi upon b into x. Okay, so we can write w. Therefore the principle of superposition it can be written as, so it can also express as fine. So just substitute the solution of xn in y1. Now what we have to do, we have to find the value of a and bn with the help of rest of the boundary condition. Now the boundary condition a comma y is 0 where y is from 0 to b. This implies an e की power n pi at the place of x I am writing a plus bn into n pi, fine, and at the place of y it is y equal to 0. So sign this term cannot be equal to 0. So from here we can say bn is equals to minus an की power 2n pi a upon b. Fine. Okay. Another boundary condition. E की power y, where y belongs to 0 to b, which imply, so you have to substitute bn, and I'm taking an outside, and then I'm putting the value of x is equals to 0. So first term after taking an outside is 1, 2n pi a by b into sine fine. So from here we can find an. Sorry, this is a by b. Okay, so 0 to b e की power y sine n pi y on b dy, and in the denominator you will get 0 to b sine square n pi y by b. So the value of integration b by 2. So I'm writing 2 by b. Now we have to integrate. So what is the formula for e की power ax sine bx e की power y? Is it correct? Into sine n pi y upon b minus b into cos n pi y upon b, where limit is from 0 to b. Fine. So this is b square. I'm taking it in the numerator. B plus n pi whole square. So after substituting, this will become upper limit. This will become e की power b. And after substituting here b, you will get 0, and at 0 sine term also 0. So the term will left with n pi b cos n pi is minus 1 की power n, plus at 0 we will left with this term. Fine. So this term is multiplied with the first term also only into. This will cancel out. So I'm taking n pi outside, and denominator is b plus n pi whole square. and 1 minus here 1, and b is also outside and b will cancel out. Fine. So you will left with this term. So this is the value of an into 1 minus e to the power 2n pi a by b. You can write the value of an from here. Okay, right. I'm writing the solution for wxy. So I'm putting the value of an 2n pi upon b plus n pi whole square into 1 minus 1 की power n e की power b, and again taking this in the numerator and convert it into sine hyperbolic term, then you will get 2 sine hyperbolic and also sine hyperbolic and pi. This is simply calculation, you can check, into sine, okay, I'm writing here this term, into sine n pi y upon b. Fine. So this is the solution for problem 2. Now what will be the solution for ux? Hence, by adding the solution for v and solution for w, we will obtain the solution for u. So just write the solution for v. Okay, this is solution for v. Fine. And here we obtain the solution for w, and combining these two terms we can obtain the solution for uxy. Vxy plus wxy. You can write in the after combining these two terms. So this is the solution. Just put the value of b and w, you will get the required solution for u, where x is from 0 to a and y is from 0 to b. Fine. Is there any doubt in this question? Is it clear? Question number 1. How to solve these type of problem? You have to break the boundary in different problem. For example, here we have given two non-zero boundary conditions. So we have to break into two problems. Okay. So problem 1, problem 2, and after solving one by one these two problems, we can find the solution for u. Is it clear?
Okay, ma'am.
Okay. Okay, let's move to the next question. Question number 2. Find the solution of boundary value problem.
Ma'am, this type of questions So, how
Yes.
much marks it will be given for the examination?
Marks, I don't know what kind of question they will give you and what the marks will distribute it. But if these question will given, then I think this will in the long type questions, descriptive questions, I think. So 80 marks question paper will be there na.
Still, we don't know the pattern of the question paper, ma'am.
Okay, okay. I also don't know the question paper patterns.
Okay.
So in the next question, we are given the boundary condition is Newman type. Fine. In first question, the boundary condition are Dirichlet type, but in this question, the boundary condition is a Newman type. And these three boundaries are zero, but only one boundary is non-zero. So we no need to construct a problem. Just we have to solve for u. Fine. So how to solve? Again, we will use variable separable method, and by using boundary condition, we will construct SL problem and eigenvalue eigenfunction, and after combining two variable solution, we'll find the solution for u, and after rest boundary condition, we'll find the constant terms. So this is the procedure how to solve. Okay. So first of all, so after putting this in equation 1, let's say this is equation 1, then we'll get, after putting and rearrange in this form, you will get this is constant. Okay. Now we have to apply boundary condition. Let's take these two boundary conditions. Okay, with the help of boundary condition, you will get y dash 0 and y dash pi 0. Fine. Is it clear? So the problem, y dash y double dash is equals to lambda y, where boundary condition are fine. If there is any doubt, you can ask. Okay, by solving this ASL problem, you will get the eigenfunction in the form of cos. Fine, because derivative is there, and by where n is 0, 1, 2 and so on, and corresponding eigenvalues minus n square. Now please solve for xn by using this lambda. This is quite simple. With the help of lambda, please try to solve for x. Lambda is minus n square. Okay, we have to solve this problem. What will be the general solution? This is OT, so you will get two roots plus minus n. So you can write e to the power nx plus bn e to the power minus x. Fine. So after solving x and y1, yn, you can write for uxy. What will be the solution for uxy? unxy or xn into yn. Fine. Just you have to substitute the value of xn and yn. From here xn and from here yn. Then you will get question 1 is quite lengthy, but question 2 is not that much lengthy. So what we have to do now? We have to find the value of a and bn with the help of boundary condition. So you will substitute after partially differentiate with respect to x, then you will get n into an minus n into bn equals to 0. That means an is equals to bn for all n. Fine. And another boundary condition, so you have to again differentiate this equation, let's say 2, and after putting pi at the place of x, you will get, so after differentiating n 2an, so you will get, I'm writing in the sine hyperbolic form directly. If you are not getting, then you can tell me. These are the quite simple calculation. Fine. Just differentiate with respect to x the equation 2 and substitute at the place of x is equals to pi and write in the form of 2 sine hyperbolic n pi. Fine. So from here we can write 0 to pi 2 cos y into cos of ny dy, and the integral of denominator is 2 upon pi. Fine. So if n is equals to 1, then you will get pi by 2. The integral for this, you will get pi by 2 if n is equals to 1, but for n is equals to 2, 3 and so on, you will get the integral value is 0. So I am taking 4 outside, so this is 0 for all, and this is pi by 2 for n is equals to 1. So from here we can say a1 is 1 upon sine hyperbolic pi, and an is 0 for all, are you getting these steps? So now we can write the solution for uxy. A naught plus a1 is 1 upon sine hyperbolic pi, and for n is equals to 1, for n is equals to 1, if you put here, you will get cos hyperbolic, okay, into cos of y, where a naught is arbitrary constant. So this is required solution. Is it clear? Is there any doubt in this question? You can ask. Fine.
Yes, ma'am.
Okay. Okay, let's move to the next question. Question number 3. So the Laplace equation in the polar form, fine, where r is from 1 to 2 and theta is from 0 to 2 pi, and the given boundary condition are how to solve this problem. Again, we will use variable separable for polar coordinates. So one is the function of r, and let t is a function of theta, which is not equal to 0. So you have to substitute urr, ur, u theta theta. Then after substituting, you will get r double dash t of theta, first term. Second term is 1 by r dash t of theta. Third term, r of r t double dash theta is equal to 0. Okay. Now please separate r and t. You can take t theta outside, and so I'm writing after rearranging. I'm writing this will equal to lambda. Fine. Just take t theta outside, and 1 by r multiplying with r square, and divide with r of r. So now we have to solve for r and t with the help of boundary condition. So boundary condition 1, u r1 comma theta sine theta, where theta is 0 to 2 pi. So from here you will get equal to, okay, at 0 and t both ends, this will equal, fine. So from here, so this is periodic SL problem as well. T dash 0, T dash 2 pi. From here, the boundary value problem becomes t of 0 is equals to t of 2 pi and fine. So how to solve this problem is regular SL problem. And lambda is real, so we have to take condition on lambda. T double dash equal to 0, so that E of theta C1 theta plus C2. So after applying first boundary condition, you will get C2 T of 0 means C2, T of 2 pi means C1 into 2 pi plus C2. That means C1 will 0. Fine. From here we can say lambda is 0. Lambda 0 is an eigenvalue with eigenfunction C2. That means we'll take constant 1. Fine. So this is first case. Now for lambda is equals to minus mu square. Please try to solve for minus mu square. And tell me the answer. For lambda is equals to mu square, solve this SL problem. Take lambda minus mu square and solve for t of theta and tell me the answer. Are you trying? What will be the value of d theta in this case? First of all, tell me the solution for d theta. After putting minus mu square, you will get plus minus iota mu. Okay, so C1 cos of mu theta, C2 sin of mu theta. Fine. Now apply boundary condition. The first boundary condition is, so after applying this, you will get, I'm taking both term in right hand side. After substituting 2 pi, and after applying, you will get from here. Please tell me the value of C1, C2. For which value of mu the non-zero value of C1, C2 will exist. So from above equation, the non-zero C1, C2 exists for mu is equals to n. Okay, therefore uh, cos of n theta and sin of n theta both will the eigenvalue. Fine. Now using lambda minus n square, we have to solve for another problem. The general solution for the problem r square r, I am substituting the value of lambda here. So this is Cauchy-Euler problem. So what will be the solution for Rn? Tell me the value of Rn. Anyone? This is Cauchy-Euler problem. Is it correct? Yes. Is it correct?
Yes, ma'am.
Okay. So for r is equals to for n is equals to 0, we'll get fine. So we can write ur comma theta as which is the product of so for n is equals to 0, we have a naught b naught ln r plus and rest of the term are into cos of n theta plus because we have two eigenfunction cos n theta and sin n theta, so I am writing the linear combination of these. Fine. So this is ur theta. Now we have to find the constant term with the help of boundary condition. Now the condition u r 1 comma theta is given sin theta, where theta is from 0 to 2 pi. Okay, you have to differentiate to r theta with respect to r, and then at the place of r you have to substitute 1. This will imply after differentiating the first term is constant, so it will become 0, and b naught upon r, and r is 1, so this is simply b naught plus differentiating first term is n into an into r की power n minus 1. Okay, so after substituting you will get an minus bn into n cos of n theta. Fine. And the second term cn minus dn, so this is dn into n sin theta, sin n theta is equals to sin theta. So from here you can compare both sides. So sin theta for n is equals to 1, for n is equals to 1, it will give n cn minus dn is equals to 1. Okay, and rest of the term are 0, and here from second term an is equals to bn, and this b naught is 0. Can you see it? I'm just comparing both sides. Okay, b naught will become 0 because there is no constant term in the right hand side, and second term is 0, so an is equals to bn we will get, and the third term for n is equals to 1 we will get cn minus dn is equals to, for n is equals to 1 means c minus d is equals to c1 minus d1 is equals to 1. Okay, fine. That implies b naught is 0, an is equals to bn, and c1 is equals to d1 plus 1, and cn is equals to dn for all n greater than equals to 1, 2. Okay, so we can write solution ur comma theta. First term is a naught from here, and second term is b naught is 0, so second term will vanish, and third term will an is equals to bn, so take it outside, so rn plus r minus n into cos n theta, and here cn is equals to dn for n greater than equals to 2, but for n we have c1 is equals to d1 plus 1. So applying these conditions we can write okay plus d1 r plus 1 by r, so the solution is, after applying these conditions, first term is from here Cn is equals to dn for n is equals to greater than equals to 2, but for 1 C1 is equals to d1 plus 1. So I am writing plus n is equals to 2 to infinity into sin n theta. So this is after applying one boundary condition. Fine. Now we have another boundary condition. We have given, okay, let me show you the problem. This is problem Laplace equation in the polar form. So we are using variable separable method. So after solving for r and t separately with the help of SL problem, you will get the solution for ur theta. After applying one boundary condition, you will get the constant value. Some of the constant value are equal. So by applying another boundary condition, which is given as, fine. So after differentiating with respect to r and substitute the value of r is equals to 2, will get, first term will become 0, and in the second term you will get n an r ki power n minus 1, and after substituting r is equals to 2, you will get n an 2 ki power n minus 1, that means 2 ki power n upon 2, so I am taking 2 1 by 2 outside, into sorry, this is cos of n theta. Okay, and this is constant term d1 into, so I'm first of all I'm writing the series Cn 2 ki power n minus 2 ki power minus n sin n theta, where n is from 2 to infinity, and differentiation for d1 into 1 minus d1. Okay, take d1 inside, d1 d1 upon r square and 1 plus 1 into sin theta. Okay, for all theta from 0 to 2 pi. Okay, now from here, if we compare both sides, then what we will get, an is equals to 0, cn is equals to 0, and d1 minus d1 upon r square plus 1 is equals to 0. Fine. an is equals to 0, cn is equals to 0 for all n greater than equals to 1, and for all cn is from 2 to infinity. So, and d1 minus d1 upon 2 square plus 1 is equals to 0. So from here d1 will give minus 4 by 3. Finally, the required solution we can write a naught 1 by 3 r plus 4 upon 3 r sine theta. You can check. I'm just substituting the value of d1 is equals to minus 4 by 3 and c1 is equals to d1 plus 1. So we'll get the required solution, where a naught is arbitrary constant. Fine. Is there any doubt in this question? So we have two problems, but we have 20 minutes left. So tell me which problem you will like to solve. Question number 4 or 5? I will write another one of them we will solve, and for another we will write the answer. You can check. Both are similar to question number 3. You can solve. So for question number 4, find the solution for boundary value problem. Again, the Laplace equation in polar form. Okay, where r is from 1 to 2, theta is from 0 to 2 pi, u1 comma theta is 0, ur comma theta is ur comma 0 is 0, and ur comma pi is 0. So this is problem of the type. If we draw the region, you will get the sector of annulus region, where ur comma 0 is r comma 0 here is 0, and Okay, and r is given 1 and 2. So we have to find the distribution in this sector. Fine. At this boundary, u1 comma theta is 0, and outer boundary ur comma theta is given, means 2 comma theta is theta, theta minus pi. Okay, problem is clear. Again we will use variable separable method. Ur comma theta, let's say this is solution, this is not equals to 0, and after substituting you will get, okay, I'm writing some steps directly. For r, satisfy and for theta, t of theta, fine, for non-zero constant lambda. Okay, so the after applying boundary condition ur comma theta is equals to 0 is equals to ur comma pi, boundary condition, t of 0, here r of r, 0 is equals to t of pi. So t of 0 is equals to t of pi is equals to 0. Fine, clearly. With this is SL problem. So we can solve. I am writing the solution for Tn. You will get the eigenfunction sin n theta and eigenvalues minus n square. Fine. So after putting lambda n for the problem, for we can solve for r. This is Cauchy-Euler method. You can apply. You will get an r की power n plus n r की power minus n. Okay, so u r theta in this case for rn into sin n theta. Okay, so after applying the boundary condition u1 comma theta is 0 for theta 1, theta is 0 to pi. You can check. We will get an plus bn sin n theta is equals to 0. That means an is equals to minus bn. Okay, and another boundary condition, That means an, after putting r is equals to 2, 2n minus 2 to the power minus n. Since an bn is equal, so I'm taking an outside. Sin n theta is equals to theta, theta minus pi. So from here, the value of the constant coefficient theta, theta minus pi into sin n theta. Okay, d theta. So after integrating, and substituting pi and 0, you will get first term 0, second term, and third term you will get cos n theta upon nq. And after substituting limit, you will get 4 cos of n pi minus 1 upon nq pi. So this is an dividing by 2n minus 2 to the power minus n. Okay. So from here we can observe at every even value an is 0, a to n is 0 because cos n pi will become 1. But for odd it will become 8 upon n cube pi 2n minus 2n minus n. So the required solution when n is odd, because for even an is 0 and for odd 8, that means 2q we can write. Fine. So this is required solution. Now we have one problem left, question number 5. I'm going to write the answer for this question. You can solve by yourself. Is there any doubt in question 4? Is it clear?
Yes, madam.
Okay. Okay. So I'm writing the answer for question number 5.
What about question, madam?
Okay, let's tell me the question.
Question
The
also.
question is again the Laplace equation in polar form where r is given from 1 to 3 and theta is in the sector 0 to pi by 2. And these are the boundary condition we have provided. So again we will apply variable separable method. We will solve for r theta and t theta And with the help of boundary condition, we will solve one SL problem, and with the help of lambda, we will solve another problem. And so that we can write UR theta. And after applying two boundary condition, we can get the constant term. Okay, this is the procedure you can uh, apply in the similar manner as we have solved question 4, question 3. Okay, so the answer is try to solve and you can match the answer. N pi upon ln 3 pi by 2 into sine hyperbolic n pi upon ln 3 theta minus pi by 2 into sine n pi ln 3 ln r, where r is from 1 to 3 and theta is from 0 to pi by 2. Fine. So you can try. Okay, this is the answer. Is there any doubt? So this is the last session for the course. Anyone want to give any suggestion or feedback? You can give. Okay, that is all from my side. All the best for your examination. All the best. Thank you, guys. Thank you so much. Is there any doubt? Any query? Okay, you're welcome, Sukhendu ji. Okay, we will leave now. Thank you so much, guys.